Welcome to qnawire.
We can say here that the person's speed, say relative to the ground, is going to be equaling the velocity plus v sub t, where here the v would be the person's speed relative to turntable, and then this would be turntable speed relative to the ground. And so we can then say that the turntable's angular speed, or the angular velocity of the turntable, equals the turntable speed at the rim divided by the radius of the turntable itself. And so the person's angular speed relative to the ground would be equaling v plus v sub t divided by r. This is equaling v over r plus the angular speed of the turntable. And so we can say that the person is to be treated as a point mass for the calculation for the moment of inertia, and we're going to apply the conservation of angular momentum. And so we can say that L sub initial equals L final, and so we can then say 0 equaling the moment of inertia of the turntable times the angular velocity of the turntable plus the moment of inertia for the person times the angular velocity of the person. This is going to be equaling moment of inertia for the turntable, angular velocity of the turntable, plus mr squared multiplied by the angular velocity of the turntable plus the velocity of the person relative to the turntable divided by r. And so we can then say that the angular velocity of the turntable is going to be equal to negative mrv divided by I sub t plus mr squared. And at this point we can solve. This would be negative 65 kilograms multiplied by 3.25 meters multiplied by 3.8 meters per second divided by 1,850 kilograms meters squared plus 65 kilograms multiplied by 3.25 meters quantity squared, and we find that the angular velocity of the turntable is equaling negative 0.32 radians per second. This negative sign simply means that the turntable is rotating in the opposite direction of essentially the angular velocity of the person. That is the end of the solution. Thank you.